Every single time you stream a movie, shoot off an email, or ask an AI for help, you're tapping into a data center somewhere. It all feels so invisible, right? Like it's just happening in the cloud. But here's the thing. The cloud isn't some digital ghost. It has a physical address, a massive hidden footprint right here on Earth. And well, it's growing so fast that it's starting to push our planet to its limits. So let's really dig in and see just how big this problem is.
So, what are we looking at here? 4.4%. In 2023, that was the chunk of all electricity in the United States that was eaten up by data centers. Let me put that in perspective for you. That's more power than every single household in the entire state of California uses combined. And this number? It's only headed in one direction, up, especially with the absolute explosion we're seeing in AI.
And if you thought that was a lot, get this. All the data centers in the world, when you put them all together, use over 30% more electricity than the entire country of Great Britain. It is a staggering amount of power, and it really pulls back the curtain on a crisis that's been hiding in plain sight, right behind our digital lives. And that gets us to the heart of the matter, Earth's hidden overload. Because this isn't just about plugging things into a wall. It's about the total real-world environmental costs of our constantly connected, data-hungry world.
So what's pushing this demand into complete overdrive? Well, first, it's the stuff we use every single day, cloud computing, massive data storage. But the real accelerator, the thing that's throwing gasoline on the fire, is the incredible rise of artificial intelligence. I mean, training and running these powerful AI models takes a huge amount of computational power, and that's putting a strain on our earthly infrastructure like we have never seen before.
Yeah, and as you can see here, the problem is way bigger than just power consumption. Data centers are responsible for about 0.3% of all global carbon emissions, mostly because a lot of that energy still comes from fossil fuels. But look at that bar in the middle, water. To keep all those servers from literally melting, these places use millions and millions of gallons of water for cooling. That puts a massive strain on local water supplies, especially in places already dealing with droughts.
So, with these very real physical limits becoming more obvious every day, some people are starting to look up for an answer. A really radical, almost science fiction kind of idea that might just be our best shot. And this is the key. We are literally running out of room and resources on Earth to do this. I mean, companies are already fighting to find places that have enough land, a stable power grid, and access to those insane amounts of water. We're basically hitting a physical wall with the way we do things now.
And this is the proposed alternative. What if we just move the data centers off the planet completely? It sounds wild, but a European Commission-funded study called Ascend actually explored this very idea, creating entire constellations of data centers in low Earth orbit.
So why would we do this? Well, the advantages are pretty incredible. Out in space, you have a limitless, constant supply of solar energy. And even better, the freezing vacuum of space is a perfect natural cooling system. No water needed, ever. Doing this would free up all that critical land and water back here on Earth, and it might even open up new ways to keep our data secure.
Sounds like a perfect solution, doesn't it? But as you can probably imagine, launching our entire digital infrastructure into orbit comes with a few, shall we say, minor hurdles. This is where a brilliant idea slams into some really unprecedented challenges.
So here's the to-do list to make this a reality. First, the launch itself. It makes no sense to burn tons of fossil fuels getting data centers into orbit if the whole point is to be greener, so we need reusable, low-emission rockets. Second, space is not a friendly place. We have to build servers that are tough enough to handle constant, harsh radiation. And third, we absolutely cannot make the space junk problem any worse than it already is.
But believe it or not, the single biggest obstacle might not be the technology at all. It's the law. The rules we have for what happens in space are dangerously out of date.
Just take a look at this timeline. These are the 5 main UN treaties that govern everything that happens in space. The most recent one is from 1984. The big one, the Outer Space Treaty, was written way back in 1967. These laws were created for a totally different universe, an era before the internet, before private companies were flying to space, before anyone had ever dreamed of putting a data center in orbit. And that right there is the fundamental problem. These are state-centric treaties. They were written when space was the exclusive playground of 2 superpowers, the US and the Soviet Union. The whole legal framework is built around what nations do, and that leaves this massive, confusing gray area for the hundreds of private companies that are operating in space right now. This slide really puts it all in perspective. The Cold War era, that was all about exploration, and it was basically a 2-player game. Today, it's a commercial gold rush. You've got private companies planning everything from asteroid mining to space tourism and, yep, orbital data centers. The old rules just don't fit this new reality, and governments are scrambling to figure out what to do.
So the path forward isn't just about better engineering. It's about diplomacy. It's really a race to write a new legal rulebook for this brand new commercial era in the cosmos.
This quote just nails it. That ambiguity, that fuzziness, creates real risk. What happens when one private satellite almost crashes into another? Which, by the way, has already happened. Who's really liable? The current laws don't give us a clear answer, and that uncertainty is a danger to everybody.
And here's what makes it so tricky. A single mission might launch from one country, use parts made in another, and be operated by a multinational company serving customers all over the world. Every single action is inherently international, which is exactly why we need clear, internationally agreed upon rules of the road.
Which leaves us with the ultimate question. Moving our data centers to space could help solve a major environmental crisis down here on Earth, but it opens up a whole new frontier of challenges. The technology is almost there, but our laws are stuck in the past. So as we stand on the edge of this incredible new era, we have to ask ourselves, who gets to write the rules for this final frontier?